Hi, welcome to the next video in our remote MCP series where you can build your own SaaS solution. In this video, we are going to take our previous video where we created a remote agentic SaaS MCP solution further by converting that into a medical advice or a doctor MCP. Welcome to Techie Talks AI. I'm Sri from Schogini. On this channel, we bring you hands-on demonstrations and insights into the latest tools and trends to help you get started with ease. Don't forget to subscribe and be a part of our journey into the future of technology. For instance, if you have an automation agency and if you have a client who is a medical doctor and would like to encapsulate the knowledge that doctor has into a medical app and expose it to other clients so that they can offer the expert advice this doctor can provide through the MCP application to rest of their users. So that is the idea. While going through this, I will also explain the problem that we can face and how we can overcome them. So first, let's look at the diagram and see what we are going to do. Then we will have a quick demo of how this application works. Then we will look at the code and see how we can run it. The entire code is available for you to clone and run it yourself. And if you have any suggestions, ideas, please come via the comment section. So let's get on. This is the big picture that we have been referring to in all our previous videos. Just a 1 minute recap. If you have a non-agentic application, the query from the user goes directly to the LLM and then LLM responds back. But that is not very useful. We have seen that in last several months, agentic systems have become very, very popular and the in thing. So agentic system sits between the user and the LLM and offers additional facilities like context. See, what is a context? That is, when you query the large language model, you should also give contextual information so that the large language model can respond back to you meaningfully. For instance, if your question is about a specific book or a specific know-how, and if you have that know-how or the book available in a database or a file, you can provide that also to the agent so that agent can extract the relevant chunks or the context from the database or the file and send it along with your query to the large language model. So in addition, agent facilitate the addition of tools. What are these tools for? LLM is essentially a language model. Even if you ask what is 2 plus 2, it is actually giving us the correct reply, treating it as an English language. But if you expect more precise response, you will need to have a calculator. And LLM will know how to use your calculator. So for instance, if I have a calculator added, and if I ask what is sine 33 or whatever, the query will go to the LLM. But I will also inform the LLM that I have a scientific calculator and it needs these parameters, whether in degrees or radians, whatever. Then this LLM will come back with the calculator name and the parameters to be passed. And the agent will use the calculator. The reply goes back to LLM and then LLM properly formats and gives us the reply. Now, all these things happen with the help of the agent and LLM. So there will be, even if you are making a single query to the agent, there will be multiple back and forth happening here to give you the correct or expected response. Agent can also validate the response and it can also retry till it gets the response in an expected way. Okay. So all these are possible with the help of agent. So agent is here to stay. Undoubtedly, whatever thinking model that you have, we will always require agents. I mentioned that agents have the facility to add or attach tools. Now, these tools can come from other companies. So how do we attach other companies' tools to our agent? So that is not easy, or that was not standardized till Anthropic launched the model context protocol in November last year. So what that has done is it has standardized the way we can attach tools to our agent. So essentially MCP works like a USB-C connector. Once you have USB-C, any type of device you can plug in. Okay, so MCP aims to facilitate that. Okay, so if you are building an MCP based solution, you can give it to your clients. You can offer it as your SaaS solution. So in addition, there are numerous advantages. So we are going to look at those advantages. So now I mentioned that there is a model context protocol from Anthropic. This protocol has got two different transport. One is SSE, service sent events, another is STDIO. Now, if you use STDIO to attach your MCP servers to an MCP client or the host, which is the agent, your MCP server also has to sit within the client, MCP client. So such a solution may not be attractive for an automation agency because you need to protect your intellectual property. In order to protect your intellectual property, slightly more sophisticated, secure way of connecting a tool to the agent is using service sent events or SSE transport. So that is, you keep your MCP servers away on your machine, you host it, you scale it, and you expose this to your paid clients or subscribers, and they can use your MCP server. So that is the idea. So what we're going to do is in the next slide, we're going to see this in a little more detail. Okay, so this is the expanded view of the MCP servers connected via SSE transport. Now here, this is from one provider. Another one can be from another provider. They all can sit in their own hosting environment. So, for example, this is my MCP solution where I have my expertise. Okay, my years of expertise in certain domain I have captured and added it as a prompt, added it as knowledge base, even tools. All those things I can add here and offer that safely through SSE endpoints. Got it? So let's expand this further. Okay, so here we have an MCP server. Let's treat it as my MCP server or the MCP server that we are building now, which is a medical advice or a doctor MCP server. That MCP server has an agent. So MCP server also can have agent or agentic behavior. We saw it in the last video, which means that MCP server is not just a tool. It is an intelligent entity with its own access to LLM. So you can choose any LLM you wish and connect it to your MCP server. Okay, but that is not all. You can have your own confidential, detailed prompts added to this agent. Nobody will have access to this prompt. Only you will be able to manage and update these prompts because it stays remotely on your hosted MCP server. You can have your knowledge base added here. You can have your custom tools or database access. All these can enrich your MCP server confidently. You only expose the service through the SSP transport. So that is the idea. So let's now see how it works. And remember, these examples are not production use cases. For production use cases, you may need to have additional protection like rate limit for your normal user, premium user. You may need to rate limit this SSE endpoint. You need to authenticate using token so that only authorized users can access. You may want to prevent cross-site attacks. You will need to ensure that your MCP server stays safe using these mechanisms. In addition, depending on the volume of use, you will also need to have scalable solution. So you may need to deploy this as a microservices architecture where these are containerized and some container orchestration platform like Kubernetes will be required to deploy it and let it auto scale depending on the load. So all these are possible now with the help of these MCP servers, especially with this SSP transport. That is a remote MCP server. Okay, so let's leave this and come to the web interface. Okay, so this is a family doctor web interface. Remember, this is not the MCP server. So let me clarify that. So we have the MCP server sitting somewhere else on our machine, and this application is sitting on our browser, and this runs on another machine, and the web application is being served from that machine. Okay, so and this web application will have the MCP host and also the MCP client. So it is slightly tricky configuration, but let's understand this. So this is my browser, and that is being served from the Python application that is running on this machine, and that machine has the agent, which is also called the MCP host. Okay, like Cloud Desktop, Cursor, they're all MCP hosts. Now, in order for MCP host to have access to an MCP server, you need to have an MCP client. Okay, and that MCP client is what is establishing a connection to the remote MCP server through SSE transport, server send events transport. This SSE is a one-way transport, one-way communication, but there is also another channel for giving instructions, commands, etc. Okay, so SSE is a streaming channel. So it is the client that is in touch with the MCP. So on this MCP server, we have our agent and all additional prompts, tools, etc. So this is the setup. So now what we are seeing here is the web interface to our MCP host, which has access to MCP client on the same machine, and that MCP client talks to our remote MCP server. So now let me first demonstrate how it works. So I have a neck pain. Okay, so we got the response for neck pain, over-the-counter medication. Okay, so painkiller it is prescribing. Okay, and the warnings. Remember, use this only as a fun tool for understanding how it works. This is not a medical advice. So I am already giving a disclaimer at the end. Okay, home remedies is there. So nicely formatted thing. Okay, so now my question is, if this is a part of the web application, then what happens is this prompt that created this report will also be revealed, isn't it? So when it comes to this MCP server solution, this prompt stays safely on our machine. So this is the working of this web application that uses the MCP server medical advice solution. So now let's look at the code. This is containerized. All my solutions are containerized because I love Docker. I was also a certified Kubernetes administrator, and advantage of Docker is if I show you something which is containerized, you can definitely run it on your machine without having to rely on any dependencies or something, because this container will be created using the same image that I'm showing you here. So this has got the SSE server, identical to our previous video. Only difference is the script that we are running is different. This is SSE server, Agentic Doctor. This SSE client, what is this for? This is only to test, because when you are developing, you will need to repeatedly execute and access your MCP server to ensure that it works, because web interface means you have to type in, press enter, etc. So, or you need to have different automation tools, and this will also help you to add your automated testing. Also, subsequent videos we will see how we can build a test-driven development for AI and AI-based solutions. And then we have the web interface. Okay, so that is it. So what we will do is, we will see how we start the application. To start the application, all we need to do is clone the repo. Once you clone, you will get this TechieTalks AI folder, and from there you can come to MCP Pydantic AI Demo 5 MCP SSE Agentic Doctor folder, and there all you need to do is to type docker compose up SSE server space Streamlit _ app. What it will do is, it will start the SSE server and it will also start the Streamlit web application. Okay, so it's up and running. So web interface is up and running, and also the MCP server. So now let's look at the SSE client, because that is much easier for us to learn and understand. I'm in the same folder. Here I'm typing docker compose run SSE client. I'm using grok. This is not the GROQ grok, this is GROK, our Elon Musk's grok. The reason why I'm using grok is, it is more open for giving us medical advice. Okay, so here it is giving the reply. This is about earache. It is giving the advice. Now let's look at this SSE client code that we ran. And initial commands are about importing libraries and getting the API keys. All the keys are provided in the .env file, and you will have .env example where all dummy keys are placed. All you need to do is to add your working keys. Okay, and let's look at the SSE client. Here we are creating the MCP server object and giving the URL to our MCP server /SSE. So this host name is what we have specified in the Docker Compose. So this will be the container name or the host name. Okay, and coming back, and then we are specifying the agent. We are not using this agent. Let me comment that out. So I am giving these placeholder agents so that you can just uncomment and use the agent that you wish to use. Okay. So I realize that even DeepSeek is not giving medical information like grok. Okay. So this is what is using grok, and this is the URL. This is how you need to access. Okay. And the model is placed here. So here I had a problem. I had to use this special prompt which I derived with trial and error to ensure that it gives back exactly the same response as returned by the MCP. So that is it. This is the agent. Here we are running. Say I have earache. Okay, so that is it. It is just result. So this IAM SSE client grok is what I am printing here. Model object dot model _ name. Okay, so the reply is here. It is actually markdown formatted reply. Okay, so if you copy this and put it in a markdown reader, you will get a properly formatted reply. Okay, so this is the response for earache. Here are some recommendations and precautions to consider. Okay, so this formatting is also something that you can prompt your remote MCP solution to make it ideal for your clients. So that is how client works. Now let's look at the Streamlit application, and finally we look at the MCP server. So Streamlit application is in this folder. So in this Streamlit, the client front-end application is using GPT-4o Mini. So this shows that clients can continue to use any language model they wish, and the MCP server stays separate and it can use its own language model. So that is also demonstrated here. Okay, so this section is identical to our previous command line client that we saw just now. That is it. Rest of the code is getting the user's prompt and passing it to the agent, and then run the agent just like we ran in the client. That is it. So that is the tiny Streamlit web application. Now let's see the SSE server Agentic Doctor application. So it starts with all the imports and getting the API keys, etc. Okay, so this is the Doctor implementation. This function is what is doing everything this MCP server has to do in terms of its knowledge. So here I have given different model selection for your convenience so that you can choose any model you wish and see how it responds. So here I have used XAI, which is the Grok LLM, and this is what is special to you. That is your prompt. So as a virtual family doctor, your role is blah, 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 and you specify how it should respond back. Clear? So this prompt stays safely in your MCP server on your hosted machine. And then everything else is similar to all our previous MCP servers. Here we are running the agent. Remember, this agent is not the main client's agent. This is our MCP server agent. In this case, we saw that our client is using OpenAI GPT-4o Mini. So in this MCP server, we are using Grok. Okay, and the response comes back here, result.data, and it goes back. And rest of the lines are handling the transport. We have gone over these lines in our previous videos. So this is handling the SSE protocol and the /messages endpoint. Okay, /SSE/messages endpoint. And then here we can list the tools available. So here I am providing just one tool, Doctor, Family Doctor for your consultation. So if you want to list the tools on our MCP client, we can uncomment this. Okay. And let's comment this out so that the client will know the tools available. Okay, see here, available tools, doctor, a family doctor for your consultation. It requires a parameter name which specifies the medical condition you want to consult about. That is the tool. So here, family doctor for your consultation, medical condition. So it requires a parameter name which specifies the medical condition you want to consult about. So that is created by the agent from your list tool here, description, medical condition. Okay. So that way, if you have multiple tools available within one MCP server, you can uncomment, you can duplicate this section and add more sections. And then here in this tool call section, you can add multiple if conditions to execute those tools and then have unique implementation functions for those tools. That is it. Clear? So we saw the MCP client, command line based client, we saw the Streamlit based web client, and we saw what it takes to build our MCP SSE based server. Clear? So that is it for this video. Next video, we will see how we can explicitly call a certain tool from your client. Okay, and what are the additional things that we need to ensure so that the client does not alter or mutilate the response received from the MCP server. Thank you for your time. Please give your valuable comments. Please like, share and subscribe. Thank you. See you in another video. Bye-bye.